Alrighty, in this video I'm going to show you how to insert the holes on all these surfaces as well as use a user-defined function to make that a little faster. So we'll turn everything back on now. And what we want to do is, for this step, we want to create an axis that's in the center face of all these other pentagons, because when we insert the user-defined function, which is just going to be the sets of holes, we want to define it as a surface as an axis, so that way they're properly aligned. So what I'm going to do is I'm going to sketch on this face over here because it's being intersected by a plane, which just allows it to be a little more a little easier to define in the sketch itself. So now we just have to pick a few references, and I don't know if you caught it, but when it picked the sketch, it flipped the direction that we wanted to sketch it on. So it's actually this face, although it's flipped on the other side. So what we're going to do is we're going to do this use edge tool, and we're going to pick these 5 edges just like that. Click OK and click close. So now we're going to draw lines from one point here to another point there and to the midpoints, because that will allow us to find the center point of that face. So now if we click OK, and you can see I was correct when I said that, is now this is the plane we were sketching on. If I would have drawn it over here, it would have shown up. It would have shown up on this side, but the orientation would have been backwards, because as you can see, the pentagons don't line up exactly from top to bottom. So what we're going to do now is we're going to insert another point, and we're going to select this line, and it places one right where we want it, right in the middle of that plane. So now turn those points back on so you can see it. Now what we want to do again is we're going to do that same thing on this side. So we'll turn those back on, select this, select OK, and we'll pick this datum. And now it looks like we're drawing on this side again, but which we're not. We'll be on the other side. Insert another point between that line and that line. Click OK. So now what we can do is, using those points alone, we can go axes, and we want to pick that point, and the control key, and pick that point. So now we've created an axis that's directly between and directly on faces. So now we can just simply, if we highlight it down here, we can simply pattern this, which is nice, rather than having to do those sketches over and over. Pattern it about that axis. And again, we're going to do it 5 times at 360 divided by 5, 72 degrees. Preview here, so you accept that. And now it's actually created an axis on every face, because opposite faces are parallel and they're aligned. You only need 6 axes in the whole thing, even though the shape has 12 sides. Alrighty, so here we go. We've got all the axes in now. What we're going to do is we're going to start inserting holes, and we can just use this hole tool over here. And we want to insert it. We'll just start on the top face. We'll insert it there, control key, select that. So now that's defined that it can't move from that surface and that axis. For the first one, what we're going to do is we're going to make it a 1/2 inch. But we don't know how deep we want to make it yet, because we want it to go about halfway through. So if I just accept this for now, and we go up to here to Analysis, Measure Distance, and select this face and this face, it gives us a distance, which you can see there. It's along that axis, which means it's straight through both faces, of about 4.5 inches. So for the small holes, they're going to go all the way through the entire figure, so it doesn't matter if they overlap inside. So if we go back down here to hole 1, and edit definition. We can change it to about half of what that was. So that's about 2.25 inches. We'll accept that. Now we're going to insert another hole, same way, same face and everything. 1.5 inches deep, and it's a 1-inch hole. My apology. And these are numbers that I figured out earlier that are going to produce a really nice shape and a really cool final product. So we'll insert another hole. It's going to be a 1.5 inch hole this time, and it's going to be 1.15 inches deep. And again, I'll post these dimensions later on in the Instructable, so that you have them and you don't have to try and figure out what I'm saying. And we'll do one more, and it's going to be a 2-inch, and it's going to be 3/4 of an inch deep. So now you can see that those are all there, and you could, if you wanted, if you didn't want to use the user-defined function, you could just as easily insert those holes on every face. But as you can see, it would get pretty tedious after a while. User-defined function. We can do this with the UDF library. So if we click on that, we want to go over here to create, and we'll give it a name. We'll just call it holes, say. Holes. UDF name holes. So we want this to be a standalone, or no, subordinate, sorry, which is going to just reference it basically to this model, which is the default. So we'll click done. And now up here it says select features to add to the UDF. So we'll pick that hole, and we have to use the control key. And you'll pick that hole, and that hole. Click OK, done, and done. And then this is the prompt, so we want the single prompt. We'll just leave this. This is just what the UDF needs to be defined as, so we'll click that. Click done again, pick the axis, OK. Done, OK, done. So now what we've just done is we've created a user-defined function that is saved in your working directory. So now if we go to Insert, User-Defined Feature, there's this holes. So if we pick that, now over here, Advanced Reference, we'll just leave that as a default. So now what it's saying is select references. So we'll pick this surface, and then we'll click on this axis, and we'll pick that. So now you can see it's created those holes. So now what you want to do is you want to just keep doing that. So there you go. I've just finished inserting all the holes using the user-defined function, and as you can see, the dodecahedron is complete, and you can see the individual dodecahedrons inside created from those holes. So now this is ready to basically be sent to either a CNC or a 3D printer, which is what I used. And I'll post some pictures later on just after this video so you can see what the final product looks like.